In this video, we're going to use the API to create data series, which will become the source pupil map. So we've got the API server with XML RPC enabled, and we're going to use Python. We're going to use Python environment. I'm using Eclipse, and I've got Python installed, and I'm using that, but you can use any Python development environment you want. This is the generic connection to the API server, and I'm going to be using NumPy because there's I'm not sure, I'm not a very experienced Python user, so I'm not sure if this is the best way to do this, but you'll get the idea. Basically, I'm creating an array of intensities, or a list of intensities, a list of E-field directions, degree of polarizations, and ellipse. I'm going to browse this. This pulls up a web browser. It's easier to look at the API in the web browser. And I'm going to say Control F to search, create data series. So that's what we're going to use, this API method, create data series. That's the method we're going to use to create the data series. We did this in a previous video. And then I'm going to also use setSourcePupilMap, and then there's several variations of this. We're going to use this one, where we set the source pupil map and we give it a list of intensities, a list of polarizations, a list of degree of polarizations, and a list of ellipticity. So we can set multiple source maps just like you can from the GUI. So if we go over to Hyperlith and we look at, I've got an example loaded. So this is the skeleton hlin file that we'll be stuffing with the source pupil maps, and I've got it already set to a custom stepper model, and in the illumination we have the pupil map illumination selected, and by default there's a pupil map that has nothing in it, just one sample point, and its intensity is 1. And this is a little bit tricky because we're basically preparing this hlin file to receive the source pupil maps from the API. So we've programmed this field, number of samples on half axis, so that's the sampling. We've programmed it with this variable here, source pupil map half axis samples. The idea is that when we load a pupil map here, or when we set the pupil maps from the API, you could have multiple pupil maps, in which case you get this variable that indexes through them. These two variables are locked to this variable, and they can be used to program your number of samples so that it matches that within the source pupil map. Of course, you can override it, in which case it would interpolate, but I'm assuming in this case that you want to use the number of samples that you have in your pupil map, in which case you program this variable into this field. Okay, so let's go over to the Python, and so this code here basically is just generic code that it says if it's looping through sigma here, and it's creating intensities for circular illumination for r less than sigma, and So in other words, it's 1 if r is less than sigma, intensity is 1, and 0 if r is more than sigma. And also, we're setting the E field direction to 90 if we're out on the x or minus x axis, and 0 if we're on the y axis. And we're setting the degree of polarization to 0.9 and the ellipticity to 0.1. So within this sigma loop, we create these data series, and then, well, actually at this point it's just arrays in Python, and we don't have a data series until we, at least a hyperlith data series, until we call create data series. And so we pass in here the sigma, or the domain, is from -1 to +1. So -1 to +1 in the y direction, -1 to +1 in the x, and 0. We have nx by ny by 1 samples, and then we're transposing it because I've mixed up the x and the y. I always mix up the x and y. And then we're reshaping it to a linear array, and then converting it to a list. So this is a bit tricky because this is a numpy array or matrix or something, which we transpose, then reshape. It's still a numpy array or matrix, but then we have to convert it to a list because the API wants to see a list of things, a standard Python list. So we're keeping track of these handles, we're keeping them on a list. So every time we create one, we add it to the list. So we append it to this list of intensities, the directions, the DOPs, and the ellipse. So we're going to have one for each value of sigma. Then, just for fun, we're going to send these to the list, just so that we can have them on the data series list of the API server. Then, up this point, we haven't really dealt with hyperlith. This is just generic API stuff that has nothing to do with hyperlith. Now we're going to use those data series that we created, and we're going to plug them into this hln file. So we're going to go to this directory and load the Python example hln, which has been prepared to receive the data series for the source pupil maps. Then we call setSourcePupilMap. We give it the 4 lists, and just for fun we'll save it as another hln file. Then we'll threshold to size, and note that I chose this as a trigger variable. So the threshold to size will do a separate threshold to size for every value of your source pupil map. So back to Python, then we simulate, and then we get the bosungs, and we'll send them to the list and matrix plot the bosungs. So it's just a line space pattern. So let's run this. Actually, I don't know how to run this. Run, Python run, I don't know. I'm not very familiar with Python, but let's go to the API server, and you can see it's running the simulations, and it should have the data on the list. See, there's the intensities. So let's look at the data that it created. Here are the intensities, which I'll matrix plot. See, sigma low going up to sigma high. Each one of these has I think 30 points by 30 points. The domain goes from -1 to +1, just like we told it. So there's your intensities, and then your E field directions are 0 and 90 in this format. And let's look at hyperlith here, and let's load the hlout file that we saved. Oh, sorry, the hln file, sorry, open hln, So Python example with sources. So now we have the sources loaded, and you can see them here. Here's the table of sources and the intensity, and then you can see that this variable list has 7 sources. We're triggering off this, and we're using the value of this to set our number of samples. Okay, and then finally the bosungs were plotted. Okay, so to summarize, we prepared the hlin file to receive these data series for the source pupil map. We used create data series to create handles to data series that represent the intensity. By the way, this is the same information that you would have saved to a .src.dsa or descript file. In fact, we could have at this point saved this data to a descript file or a DSA file and loaded it in here in the loaded it in here by saying load.src.dsa file. Okay, so but instead of saving it and then loading it, we actually used the setSourcePupilMap API to actually program it in there, and then we ran the simulation. So there's data series all over the place in Hyperlith, and you can follow the same format if you're setting the Jones pupil, or if you're setting a laser spectrum, or a surface, or anything that requires a data series. You can use the same idea.